Go over the options, the actual answers. And if you didn't have yours yesterday, I'm just counting it late because it's ridiculous. We had like so much time for this. Okay, 1, answer. What letter? Raise your hand if you said D. Okay, actually, I'm gonna go over this one by one. All right, so answer for this one, because I believe that you have the capability to do so. You're going to see these numbers, and then you have to consider the moles of each, and then you're going to have to figure out what kind of problem it is, right? We have a salt and water. First thing you think of is maybe salt hydrolysis, right? It's not an acid-base reaction. It's not an acid or base. It's a salt, so we have to say salt hydrolysis. We have salt hydrolysis, and this particular salt makes a strong conjugate what? Which is it? The K plus or the F minus? Okay, so the F minus will react with water to create what? Thank you. So, oops, HF. So this is considered a strong conjugate base, and if that's something you're not familiar with, that's like one of the questions on the midterm. You should know that it is a conjugate base because it does make hydroxides, but the nature of it being strong is going to be actually forcing an excess amount of hydroxide formation because it's going to force the reaction with water. So anyway, since this is acting as a base, you must find the Kb of it, right? And the Kb of the Ka, and the Ka is associated with its parent, hydrofluoric acid. So if you're finding the Kb of the Ka, you'll know that you'll see the only thing that's got Kb is D, and whenever you find the hydroxide concentration, you'll be able to find the pH. So this kind of walks you baby step, baby step, baby step, but you'll know you're finding hydroxide to find pH eventually. Are we okay with salt hydrolysis and the thought process there? All right, so I'm trying to walk you through the thought process as well. Next, we have, what is your mixture of? Salt and water again, right? So you're like, all right, salt hydrolysis. What did you guys say the answer was for this one? C. And this one is actually just the opposite of our first one because we have salt hydrolysis, which is the strong conjugate. Ammonium. And I'm going to write out the reaction just to prove it to you, right? Because I want you to be able to do everything that you need to. And so this is going to be acting as a strong conjugate acid because it's going to donate to the water to make hydronium and ammonia. Well, ammonia has a Kb associated with it. What is it? Because we've used it like a bunch now. 1.8 times 10 to the negative fifth is the Kb of ammonia. So you would, since it's acting as an acid, you would find the Ka of the Kb of ammonia, and then go through your ice, solve for X, and X is going to be representing the anion, or I'm sorry, the cation here, which is the hydronium. So that would be finding Ka, eventually finding hydronium, and finding pH. 2 for 2? Some of those. Okay, that's our salt. Then we have, what kind of thing here? What do we have?
Strong acid.
Okay, so I'm just going to say acid-base reaction, right? And this acid, anytime you have an acid-base reaction, that means you have to allow them to react. So are you going to be setting up an ice box or BDA? BDA, because you allow them to react. So if you could allow them to react, you might want to look at the moles of both of them to figure out who's in excess at the end, if there is one in excess. How many millimoles each? 50 times 0.2. What's 20% of 50? 10. So 10 millimoles, 10 millimoles. Guess what, guys? They're both going to react and run out at exactly the same time, right? What do they make when that happens, though? What salt? They're going to make ammonium chloride, right? A salt. Spell salt. Okay, so this is an acid plus base makes that salt. And that salt is just hanging out with water, right? So what kind of problem is this? It was an acid-base reaction, but we're done with that. What do we have now? No, I have no strong acid. I have no acid or base left over. Remember, these ran out. There are 10 millimoles of both of them.
Oh, so then it's just salt hydrolysis.
Right, so I'm going to put LR here to represent they both LRs. So then again, we have salt hydrolysis. And if you're undergoing salt hydrolysis, this question was exactly the same as this one, essentially, ammonium chloride versus ammonium bromide. So it's going to act as it's which ion is important here? The ammonium. So basically, you had acid-base reaction. You made a salt, because that's the only thing you have left. You have to undergo salt hydrolysis. The salt hydrolysis component, or the actual ion that undergoes salt hydrolysis, is ammonium, and it's going to make uh, hydronium. So you must find the Ka of the Kb. Again, this is C. Okay, so this was D, this was C, and this was C. So once you did 2, you should have been able to do 3 quicker. We okay with that? But that's a thought process right there, big time. And that's an acid-base titration. You'll see some review of that in the videos today. Now we have another reaction, right? Acid-base. But what happens here? Okay, we know they're reacting, we know they're neutralizing. The strength does not matter at this point. We need to look at their values, guys. So 10 millimoles here. And how many here? Is it 10? 25 times 24? Yeah, because this is number 4. Yeah. So this is 10 millimoles and this is 10 millimoles. And I usually just write a note to myself to say that's equimolar. Equimolar. It's not equimolar. It's just no L there. So they're equimolar. They run out, right? They fully react with each other. What do they make? What kind of salt in this one? So sodium chloride, right? Which is a neutral salt because you know its parents are strong and strong. But what's actually causing this to be neutral? This is a review.
Whenever they react with water, they immediately go back.
Okay, so since they go back, the only thing controlling pH is what here? Water. So since this is with water and both of these ions are weak conjugates, they will not react with water very well. So then water is your predominant controller of the pH, and it makes equal amounts of hydronium hydroxide. So its pH is 7, which is letter F. Yeah, letter, is this F right here? E, F. Yeah, pH 7. Okay. 5. I know you're going to say we have a weak acid and strong base mixture, but tell me more. What do you know about their values? This one again is 10 millimoles. This one's 10 millimoles, right? Okay, but what do we make here? Because we know that they're equimolar, they're going to run out exactly the same time. What do they make? So sodium cyanide, and from the 2 ions, which ion is the stronger conjugate? The one that's going to react with water, which is cyanide. I'm going to write that right here. Cyanide reacts with water to make what? Or maybe what is it acting as? Okay, so it's going to make HCN. So the water is donating the H over here, HCN and OH minus. So it's acting as a base, and so therefore you would find the Kb of the Ka. Blah blah blah. Answer choice what? D again? Yeah, because is that the acidic, or that's the basic one? D is the Kb one, so you're going to be finding pH the same way as we have in the others. This was F, this was D. Okay, next, what do we have? Look at number 6 for me. What do we have? Thank you. How do you know it's a buffer? Okay, it's a weak acid, and it's conjugate base in the form of a salt. All right? Okay, so we have a buffer. What letter are we using then? G, which is the Henderson-Hasselbalch equation. That's an easy one if you recognize the fact that it was a buffer. Next we have what? Okay, so that's helpful in terms of us like figuring out what indicator to use, what the titration curve might look like, but I want to know how to find the pH. What have we been doing for all of these, pretty much? Figuring out the moles of both, right? So this one is, again, is 10 millimoles. This one is not 10, so like 8. Is it 8? Or 20% of that is 5, thank you. Okay. So 10 millimoles of that, 5 millimoles of that. What happens when they react? Or maybe tell me what's left over when they react. Okay, so there's excess KOH, so there's 5 millimoles of this left over, of the KOH, and what else? I know there's none of this left over, but we know they reacted, right? What did they make? Potassium fluoride, which I'm just going to call a salt, and we know that salt has a weak component to it, right? So, like, we have a strong base left over and then a salt. Who's controlling the pH?
Just strong.
This is strong base. So, answer choice, the A. So, OH is in excess, so it's going to be the predominant control of pH. Okay. Next, we have cyanic acid and potassium hydroxide again, but the values, you see that they're switched in location. Their values actually switch as well. So, again, we have same numero, 10 millimoles of this and 5 millimoles of this. All right. As they react, we know 5 millimoles are going to be consumed when you subtract 5 and 5, right? So what do we have left? So we've got 5 millimoles, I'm just going to put after right here, 5 millimoles of HCN left over, and what? We know this one's the LR, so it's gone.
Then we have the KL, or KC.
We have potassium cyanide and water. How much potassium cyanide do we have? 5 millimoles, because it's being subtracted and added, right? So now, what do we have here? We have a buffer, because it's a weak acid, and it's conjugate in the form of a salt. But this is a special case buffer. What do we know here? We actually know the values, right?
Right.
This is when you have equal amounts of the weak acid and its conjugate. So, what answer choice? It's E. Sorry, I'm trying to get you to see that it's the half equivalence point. E is when, so this is the Henderson-Hasselbalch equation plus the log of 1 over 1. So if it's 1 over 1 are the same, then that's going to give you the log of 1, which is 0. And so that's why that's not written. So the pK is equal to P or to pH, meaning it's at the half equivalence point. So when you have equal moles of your weak acid and your conjugate, then that's the half equivalence point. So that one's slightly different, but it's still a buffer. Okay, 2 more. Ammonium chloride and sodium hydroxide. What do we know? This is 10 millimoles. This one is 8 millimoles. Okay, so what's left?
2 millimoles of the salt.
Okay, so 2 millimoles of this is left over because the 8 of it reacts. This is after. And then this is gone. That's our LR. And then what do we make?
Wait, but the salt doesn't react.
Oh, sorry. I'm just going with the flow here. Yeah, this is a salt. This is a strong base. These two things, well, no, this part of this will react. This right here. Did I write this down right? Yeah. This ammonium cation will react with the basic part of sodium hydroxide, right? Because it's gonna have the ability to donate as needed to make ammonia and water. And since we have, is this 8 millimoles?
Yes.
Did I do that right? Okay, I wrote, sorry, I'm on the wrong line here. This one is 10, this one is 8, so at the end, when this reacts, we're going to have 2 millimoles of this left over, and then we're going to make 8 millimoles of this, and then water. Yes? So what do we have here? A buffer, and you can use the K, or is this G? You can use the pKa of this or the pKb, you just have to find what you need. So this information here can be swapped for pOH if you need to, but you can actually plug it right into that. Okay, that was for number 9. And then number 10, we have a strong acid and ammonium chloride. What do you have here? What did you guys say? Wait on you.
Well, it's a strong acid.
Right, so this one, since we have ammonium chloride, we have the conjugate acid. Weak conjugate acid, or actually strong conjugate acid, but whatever, it's a conjugate acid. And strong acid here, there's no reaction. So since there is no reaction, it's also not a buffer. It's just going to be a strong acid controlling pH, which is letter B. Okay? All right, write your score at the top. I want to see what you guys got on that one, because this is practically everything we've covered in the last part of this unit, okay? The last thing is for us is titrations. And I was going to have you guys do another inquiry lab, but we'll do instead of doing 2, we're just going to do 1, which is our titration stuff. we'll do that next week. So I'll tell you guys about that procedure stuff. I want to see your buffer problems involving buffers 1 through 3. I'll check those at the end of class. Go ahead and grab a laptop. Okay. I'll get off of your desk whenever I come back there. And go to my website. Oh, I didn't do that. Do that one here. This is I printed up 6 slides of notes with some of the questions on it that are embedded in the video, and then some pictures. The top copy is a little weak, but the rest of it's fine. So this will help you a little bit of taking notes. And the first video, I expect you to take some notes, but you probably won't take as many because a lot of it is review, and you'll just see me going over some questions. The second video, there's new stuff in it. You definitely want to watch that one. Even if you watch it double time, you need to watch it for content. And then these are like 15, they're 10 to 15 minutes a piece. Okay, so some of them are short, most of them are short. I'll show you where things on the website. So,
Alright, hey guys, we're gonna go.
I'm so weird. Okay. So on the website under tonight's homework, I just put part 1, 2, and 3. Part 1 is more review. Watch that and write down what you need to. It shows you how to solve problems. If you're good with it, then you should be fine. If you still need help with this, please watch that intently. Part 2 is a lot of information about indicators. That'll be helpful on your lab analysis from your lab yesterday. That's why I didn't have you guys finish your lab analysis, because you probably want some more background information. The third one is just finishing up part 2 because I just didn't finish. The demystifying curves is actually by this lady named Renee McCormick at the National Science and Math Institute, and hers will come up in a video like this. So it says ABChem interpreting titration curves, and this I copied for you. This actual worksheet in your packet. It's gonna be towards the back of your packet. Just got pictures of curves everywhere on it. So that is a good one to watch. I talk a little bit about it in the video 3. So if you want to go through that and fast forward her or do what you need to see what you need to there, I've given you that worksheet you guys can take notes on. Okay? So we have a little bit more than an hour. You can finish these in an hour. All right? But I need to talk to individuals. So as I need you, I'll call you up for FRQ talk. Bring your FRQs with you so that we can talk about this together. And the rest of us will I have that sign up sheet on my board. I'll have you guys sign up for times to come talk to me. That works for you guys. And go for it. Any questions? Okay. If you don't have earphones, go hide in the corner and sit down. Or spread out. Spread out anyway. You might want some elbow space. And you know I'm a doofus on most of these videos, so you can't laugh at me. I like crack jokes and stuff.